Hello, hello. Are we live? Looks like we're live. Okay, today I'm going to keep working on my interpreter. Today I'm going to implement a times equals, and if I have time, a divide equals operator. So in the last couple streams, we did plus equals and minus equals like this. These are called compound assignment operators. It's not just assignment, you're doing an operation in addition to the regular assignment operation. So let's clear this out and edit a new file. So this is what we did last time. At the end of this, well, yeah, you only use let the first time. You don't use let on subsequent invocations of a variable. So this is what we did last time, and at the end of this, I should be 7, and this whole program should return 7. That's my cat jumping around. I think she was just up on the counter in my bathroom. Yeah, so we got 7. That's exactly what we expected. So today we're going to work on times equals to begin with. So, like let's say we had 4, and we did times equals. This is not even going to lex correctly. It's going to say it's not expecting the equal sign after the asterisk. So you see it there. I think we can actually scroll up a little bit because they're cascading errors. So yeah, it's not expecting equal sign. And then there are a few things that it cascades through. First, it could be a number, then it could be a semicolon, although not really. You wouldn't really expect a semicolon there either. Then somehow it expects a number again, and a semicolon again. So I really need to clean up these cascading errors. I fixed a couple of them, but this one is a little bit out of hand. But my primary focus is getting the interpreter working correctly, and then having perfect error message is a little bit secondary. Even though I've put in a lot of effort into this, like I show the line number here, I underline with a caret the exact column where the error is. I show the file name where the error occurred. I have like different colored text, red for the error, cyan for the line numbers, and then bold, non-bold. But yeah, my primary focus is just getting it working correct when the syntran source code is correct, and then diagnosing malformed code that's lower priority. So let's dive into that. With all the refactoring that we did for plus equals and minus equals in the last few streams, it shouldn't be too hard to add new compound assignment operators now. So, basically everywhere we have a plus equals or a minus equals, let me search for minus equals. Everywhere we have one of these, we're going to add, I think I'll call it star equals. I don't want to type out asterisk. Anyway, I'm already calling the star token here. So it would be weird if I called it asterisk now. I should at least be consistent with what I've done previously. I think I want to have this. Yeah, okay. Sorry, just doing some window management in the other monitor. It's going to be 69. Very nice. Okay, so this one is a little bit complicated because for the other two character tokens, we have minus equals. There's a select case statement, which select case is the Fortran version of switch case. So we have a big switch case block to select the first character, and then within that, for the two character tokens, we have an if-else block. So for minus equals, that's fairly straightforward. For star equals, we already have a star operator. That's for exponentiation, or what you would use the PAL function for in the C language. C doesn't have an operator for exponentiation. That's one of my big gripes with C when you're doing a lot of numerical work. Why Fortran? Hey, welcome to the stream. Thanks for tuning in. Fortran is what I use for work. I've been using Fortran for about 10 years. I know it has a bad reputation, like, oh, it's from the 1970s. It's only legacy code uses Fortran, and why are you using that in 2023? Fortran is a modern language. They have a nice new website. If you go to, like, if you search Fortran, I hope it's the first result these days. No, there's the Wikipedia page, Fortran Lang. Yeah, this is it. So some people put together a nice website for the Fortran language. It'll tell you all the pros and cons of Fortran versus other languages. The best thing about Fortran, in my opinion, is that it's an array-oriented language. So let me get out of this interpreter. I'll give you a quick Fortran demo. So you can do things with arrays that are a little bit more difficult in other languages. If you've ever used MATLAB, it's kind of like that. MATLAB is inspired by Fortran. I already have one here. So, okay, here's a new one. So let's make, there's a lot of boilerplate here. Everything that I've typed so far is boilerplate, but now let's make an array. Yeah, IV for integer vector. And then to allocate memory, there's this allocate function. So let's make it 3 elements big, and then I think this might be optional in more modern Fortran. I think you can automatically allocate things. Let's do 4, 5, 6, and then I have the G-Fortran compiler installed. So the way that I compile Fortran is just G-Fortran. And I didn't do anything, so I want to at least print this. First of all, you can just print an array, like in C++. The anti-compiler propaganda guy is back. I'm using a compiled language right now, so hold your horses. MyStran asked why Fortran, so I'm going through a quick Fortran demo. Yeah, so first of all, you can just print an array. Like in C, I think you need a loop if you want to print an array to std out or printf an array. Even in C++, if you're using the built-in stream IO with stdc out, then I think you need a loop to print an array. But look, we just printed an array with no loop in Fortran. And this is totally built in. You don't need third-party dependencies like in Rust. There's nd array and n-algebra that can help you with array operations. But in Fortran, you can just print it. You don't need to do anything. But we can also do math. So we can say iv equals iv plus 1. I hope this is going to work. And then let's print it again. I'm a printf debugger. Loop and map, yeah, map in Rust. I'm not really a Rust expert. I forgot to recompile. Sometimes I Google something in Rust and it's like, oh, use map like this. And I'm like, that's confusing. I don't know what map does. That's like magic to me. So look at that. We had 4, 5, 6. We added 1 in one line of code. And now everything is 5, 6, 7. True plus true equals 2. No, I don't think you can cast things like that in Fortran. Let's find out. Let me just close this htop window. Yeah, I think this is not critical. There we go. Now we have full screen. I know some of it's going to be hidden by my webcam. So let me put this always on top window behind. Okay, yeah, functional languages are another thing that I'm pretty weak with. So I don't know Lisp. Yeah. Yeah, map is something that I need to learn. So what was I doing? Oh yeah, let's see what happens if I try to do true plus true. I don't even need to make a variable. Hey, Kelly. My cat is going nuts in the other room. So I think we can't use plus on logical operands. I think this is going to be, yeah, that's a compile time error. Operands of binary numeric operator plus are logical and logical. Fortran has logicals instead of booleans. So these true or false things, they're called logicals in Fortran, where every single other language calls them bool or boolean or whatever. Yeah, so there's compile time type checking. It's a compiled language, so it does stop you from doing this. If you actually want to do logical operators, logical operations, you use and. I really find the syntax annoying in Fortran, where a lot of these keywords have dots on both sides. So the true keyword in Fortran is dot, true dot, and the and keyword is dot and dot. I don't know what the history of that is. I don't know why they didn't just use and without dots, but this is how it works. Did I write that? Yeah, so that compiles. And then here's an inconsistency. When you print a Boolean, instead of printing it the way it is in Fortran as dot true, it prints it as capital T, and false is just capital F. So there are some inconsistencies there. There are definitely some quirks to the language, but the big thing is array operations. We can do this in one line of code without using map. You don't have to use any functional programming. So I think that's pretty cool. And it's not just addition. You can do scalar multiplication. You can do a vector plus another vector, as opposed to in this case where I'm doing a vector plus a scalar. All of that stuff is built into the language. Anyway, I'm going to get back to the interpreter. So buggy worm, I think you were watching me a little bit last weekend. Today I'm just doing the times equals operator. But I've done enough refactoring in the past couple streams that I think this should be a lot less work than minus equals and plus equals. So first of all, we need to lex it correctly. What do I want to open? Buffer 5. Here we go. Yeah, so right now this isn't even lexing correctly. Kelly. My cat is going nuts in the other room. Kelly. Never mind. Okay, yeah, so that's not lexing. The first thing I'm doing is adding it to the lexer. we already have a star star operator. So basically going to copy this and make an else if. Fortran is an imperative language. Anti-T, oh, I was like, what does T stand for? Is T an acronym? No, this is not. Yeah, I guess this is anti-T propaganda, but how do you know what's in my mug? It's an opaque mug. Can you really tell what's inside of it? It is coffee, so you got me pegged. I'm a coffee drinker. Yeah, yeah, it's historical. Fortran is one of the oldest languages. I think it's a little bit older than C. So why do they have dot true dot as the keyword? Because there was no standard back then. There was no existing convention of other programming languages, so they just picked something and stuck with it. And every other language picked something that made more sense, but that came later. They sip differently. Yeah. I guess the viscosity of coffee and tea are different, especially when you have like cream in the coffee. Okay, so if we have star star, this is the S star token. That's what I use for exponentiation. But if we have star equals, then this is going to be the star equals token, and the text is like that. So I think that's it for the lexer. I'll need to add it to this list. And then, oh, is binary op allowed? So this is part of the type checker. It checks a binary expression, and it checks if the types of the left operand and the right operand and the operator are compatible. So yeah, Fortran is from 1957. Thanks for looking that up. Lisp is from 1960. Yeah, I guess it makes sense that Lisp is that old because Emacs is basically built in Lisp. But I forgot that Lisp was that old. C is from 1972. COBOL is from 1959. I've never used COBOL. Why is my camera out of focus? Here we go. I'm kind of interested to look into COBOL. I never hear good things about COBOL. I don't know if that's accurate or not. I'm sure people hear a lot of bad things about Fortran, and I think that's inaccurate. So I'm curious if COBOL is the same way. Like if there's anything good to COBOL, or if there's just a bunch of legacy code that people have to maintain with it. Oh, yeah, the Mo Landworth. Yeah, it was all .NET. It was all C sharp. It's funny because I don't know C sharp either. I know a little bit of C++, so C sharp is kind of like similar enough that I can sort of follow along. And also he explains things as he goes through. Uh, but yeah, there's some weird object-oriented stuff with C sharp that I didn't totally understand, and I was surprised. Like, what? You can do that? Like, you can just have stuff that's completely polymorphic? Like, uh, yeah, C sharp is a little bit different for me. So anyway, we want to define the operands that the star equals operator can take. So basically it can take a numeric type on the left and a numeric type on the right. So it's like all of these other operator tokens. And the numeric type is either an integer type or a floating point type. So yeah, we have minus equals right here, and then I want to add star equals. And then this is in the evaluator already, so I think the hardest part of this feature is just going to make a multiply function, which I have that code elsewhere. I just need to copy paste it and refactor that into a function. And I'm just going to put a to-do note here for now. So I think this should lex correctly now. Yeah, we got to that to-do note that I put in. That to-do note is in the evaluator. So there are sort of like three phases to my interpreter. There's lexing, and then there's parsing, and then there's evaluation. So the fact that we have an error in evaluation means that the lexing worked and the parsing worked. And I've been on the stream for like 21 minutes, so I think I did that like marginally faster than the last couple compound assignment operators. So now for plus equals I have an add function, and for minus equals I have a subtract function. Now I need to make a multiply function. What sort of parser do I use? Ooh, I probably don't know enough about languages to answer that correctly. Actually, yeah, I think it's top down. It's a recursive descent parser. So actually, I was just talking about this with Buggyworm. I started this language based on a series building a compiler from Emma Landworth. And I only watched about half of the episodes in this series. But at the beginning of my language, I was following this like almost verbatim. I was just making like a copy of his C# implementation into Fortran. And I eventually diverged. Like I have semicolons at the end of each line and minor differences like that. So it's not the exact same language that he built. But yeah, so does he? I'm sure he mentions the idea of a recursive descent parser at some point in the series. So I think I'm following the same architecture as that. If I go to, where is this thing? So where do I parse a translation unit? Yeah, so this is like the entry point of the parser. No, I don't think I'm using a stack parser. I don't really know anything about that. I kind of just dived into this project without knowing anything about programming languages, or, well, I know things about programming languages, but I don't know anything about parsers. Uh, yeah, so I really know absolutely nothing about stack parsers. Maybe those are way better than recursive descent parsers. I have no idea, but I kind of just watched like half of one YouTube playlist and then started doing this without having any idea what I'm doing. But I think that's fun. Uh, so I might do a lot of stupid stuff. This language really isn't efficient. It has a horrible memory leak somewhere that I need to fix. So like, don't expect perfectly optimized results when you run this. Yeah, neither is better necessarily, just a different way of thinking, comparing top-down or bottom-up parsers. Is there LSP support for Fortran in NVim? There probably is, but I'm not using it. I think LSP is like a plugin for NVim. Is that right? I haven't set that up, so this is just the default syntax highlighting that you get for Fortran in NVim. Like, function is a keyword. This is the name of the function, so that's just my function name that I picked, so that doesn't get any special highlighting. Unit is a keyword. This is probably bad, and I shouldn't be using unit as the return value of my function. So that's highlighted red for whatever reason. And then types like class, type, integer, those have their own highlighting. Comments are highlighted. So this is just the default syntax highlighting that you get with NeoVim or regular old VI Vim. Works the same way with Fortran. Anyway, like this is the entry point of my parser. It parses a translation unit, which I'm only working with one translation unit right now. You can't like include another syntran file inside of your main syntran file. It's just all one file. So yeah, it loops until the end of file token, and then it parses whether you have a function declaration or like an executable statement, and it recursively descends by calling these other parse functions. Like this parses a function declaration, and this parses an executable statement. Can I tell you 2 random words? Correct horse. I think highlights come from tree sitter. LSP offers like code references. Oh yeah, like if I wanted to jump to definition, like if I wanted to jump to the definition of parse statement, I don't have a good way to do that right now. I kind of just search for parse statement and then keep hitting next until I find it. So I think I've heard of other people using C tags for that. I have that on my list of things to try with Vim, but I also like to keep my Vim setup sort of simple and with a minimal number of plugins. Not that I really have anything against plugins, but right now I think the only plugin I'm using is for this Groovebox color scheme. So I might look into C tags eventually, but I haven't done it yet. Unga bunga, those are 2 good random words. Vanilla, yeah, I have a fairly vanilla setup. I do have my dot files on GitHub, so if you can check my links, you might be able to find that, or I can send you a link in the chat. Anyway, yeah, then. Yeah, smart features are distracting for the most part. I mainly use tab completion, like if I type PAR and hit tab. I do have a custom key binding set up, so I actually use the tab key. If I hit tab, I just cycle through completions. But I don't have anything smart, like if there's a parser object here, and then in Fortran we use the % instead of the dot sign, like in C, to get members of an object. So if I start typing parser and then %, I can't tab complete through the members of this thing. I can only tab complete through things alphabetically. So I'm missing out on things like that, but I keep it simple. Links, sure. Yeah, I can paste a link in here. Volume down. Yeah, I don't think all keyboards even have a volume down key, so I can put in a link for my dot files. If you find my GitHub, I have 2 different dot files repositories. Come on, where's my GitHub? We'll start here. So I have an old repository called just dot files that has the dot files that I used to use with standard Vim. But now I've started a new repository for my new NeoVim and Tmux configuration. And that's here. I'm using the Lua scripting. So I'm not using the Vim script. I have everything in init.lua. And there are a couple of subfolders here that are included, but basically everything is in init.lua. So I will put a link to this in the chat. And there you go. Your dot files are loaded. Yeah. I just have a hodgepodge of things that I've seen other people use in their dot files. Oh, that's right. Fern of Sigma, you're the guy that programs on your phone. So yeah, okay. Volume up, volume down. That makes a lot of sense for tab completion. For a long time, I didn't even realize that NeoVim has, or even standard Vim has tab completion built into it. If I go to my configuration, that's wrong. Oh my god, I cannot type today. There we go. Yeah. Yeah, mad props to Fern of Sigma for developing on a phone. I can't even remember what the key is. So what do I have tab mapped to? It's slightly complicated. I have to use a function, but Control P is the default autocompleter in Vim. Like Control P searches from above, which is usually the way that I want to search. Like whatever I've used just before where I'm typing, that's what I want to complete to. And then I think the other one is Control N, and then Control N will search below where your cursor is and use those things alphabetically as the first completion. So I find that one less useful. I like to use Control P. At first, I didn't even know that this was built into Vim, and I was using a Vim plugin called supertab.vmb for tab completion. But as far as I can tell, it's just this, like it's this 15, 20 line function. So when I migrated from Vim to NeoVim, I couldn't find this plugin in like a Lua version, so I just wrote this, and I think that's the whole thing. Yeah, so those are my dot files. Okay, now where were we? I think we have to evaluate star equals. Yeah, so this is where the error is. Now the chat is talking about indentation in Python. That's one of my big gripes with Python, is that the white space is significant. Fortran is like that a little bit too, but I think I prefer languages where you just have a semicolon at the end of the line, and then you can do whatever you want with white space as long as you have a semicolon. Another Python true plus true equals 2 pog. Yeah, dynamically typed languages. They can be cool sometimes because you can just develop things quickly, but I think it's a little bit dangerous. So I think we need to implement this multiply function. So instead of subtract, it's going to be mult. What's the Fortran convention? Fortran has something built in. It's, doesn't it? Matmul. Okay, there's no underscore. So I want to check my naming convention is somewhat consistent with something that exists. Fortran has matmul. There we go. The syntax highlighting finally kicked in. So it has matmul for multiplying matrices. So I think I'm just going to call my function mul in that case, as opposed to mult or multiply. And then let's get those vertically aligned. There we go. And then I need to define this function. First of all, I want to see where I've done the regular old binary multiply. So this is similar to the code that I'm going to be copy pasting from. But I've done different things with addition and multiplication to handle the types. So I think I'm going to copy and paste this from somewhere else. So I have a to-do note here. Once I get done with the compound assignment, I'll go back and refactor this one too. So we need a function like that. And I think I can copy paste it from here. This is the subtract function. I'm going to copy and paste this, and we're going to make a multiply. We're just mul value t. I'll give it a short name so that I can just call it mol instead of mol value t. Because the types that this function is going to take is it's going to take a value t type and multiply it with another value t. All right, there's more stuff going on in the chat. Let me catch up. Yeah, significant indentation is annoying when you need to shuffle code around. Yeah, like if I want to add an extra if block around everything and then I have to indent everything in between. Well, I do that anyway because I like my indentation to look nice, but the fact that that's going to cause a syntax error in Python is pretty annoying in my opinion. You must hate YAML. Oh, is that in response to my strain? Yeah, I'd like to learn more about Lua, because I'm using Lua for the Vim script, but other than Vim script, or th this new version of Vim script, which is using an existing programming language, other than this, I've never used Lua, so I'd like to go through some Lua tutorials and learn what I'm actually doing here, because I just like blindly copied and pasted other functions. Like, why is this thing at the end of a function? That seems weird to me. Oh, this is all part of the key map. Okay. Yeah, so this is an argument to key map, and then the function is an argument of key map as well. Yeah, so I need to learn more about Lua. The Lua grammar is simply designed in such a way that it can be parsed just fine without there being any explicit indication about where a statement ends. Yeah, JavaScript is kind of like that. I find JavaScript confusing because you can use semicolons to end a line, but you don't always have to. And then it's like, well, when do you need it and when don't you? Hey guys, thanks for tuning into the channel. Oh, this is a bot. Never mind. Sorry to get distracted by a bot. Does JSON have to escape Unicode characters? JSON? So I don't think I'm using JSON anywhere here. Oh, did you mean Fortran? Oh, were you looking at the README? Yeah, so if I go back to Syntran, so Fern of Sigma asked, does JSON, I think you mean does Fortran, does it have escape Unicode characters? Can't I just raw dog the multi-byte characters in? I think maybe you were looking at the README here, where I'm saying that only ASCII strings are supported, but like Unicode kind of works, maybe. I don't know. Fortran doesn't really support Unicode, so I've never worked with it, and I've never put that much of an effort into getting it to work. So, yeah, there's probably some way that you could get this to work. Oh, you're sending Unicode text in YAML. Okay, so you are asking about JSON, not Fortran. Sorry about that. I know in XML, this doesn't really have anything to do about Unicode, but in XML, the way that you can encode arbitrary binary data is by base 64 encoding it. Because like in an XML string, you're not allowed to have like less than signs or greater than signs because those are part of the XML syntax. There's some weird escape sequence, like I forget what it is. But the way that you can get around that, and it works for every character without having to learn the proper escape sequence, is that you just encode everything as base 64, and then you can put that base 64 string directly in the XML. I think you can do the same thing with JSON. Yeah. Obviously, if you index a UTF-8 string by byte, you don't get characters. That's a problem that I have in Syntran because Syntran is implemented in Fortran, and Fortran doesn't support Unicode, so neither do I. If you try to do this and then index it by bytes, you get emoji bake, or I don't know how to pronounce this word, mojibaki. It's Japanese. Yeah, you get gibberish, so don't try to do it. So we need to go ahead and implement this multiply function. And that's going to be pretty easy. Basically, everywhere I see a minus sign, I'm going to replace that with an asterisk. This is a very wet way of programming. Yeah, I think those are all the ones that I need to replace. This only works with integer types, so I think I'm okay there. I might want to multiply strings. Eventually in Syntran, I might want to say if you want to repeat a string, you can use the multiplication operator to repeat a string multiple times. But I'll do that later. For now, multiplication will only work on numeric types. So I think this might compile. Let's see what happens. "12, would you look at that?" So I starts as 4, we do I times equals 3, and I ends up being 12, so that looks correct. Oh, Mojibake is a Japanese website. Yeah, I didn't know that. Yeah, if you parse UTF-8, you only get yourself to code points, and then a single logical character might involve multiple code points. Yeah, because in Unicode, some characters are a single byte. Like it's backwards compatible with ASCII. So the 128 ASCII characters, which are 1 byte in ASCII, they're also 1 byte in Unicode. But then you can have way more characters in Unicode, like practically an infinite amount of characters in Unicode. So some of them take 2 bytes, some of them take, I don't know, 4 bytes or 8 bytes. So not every character is just 1 byte. And then, yeah, if you try to index an array by bytes, then you get just like part of a Unicode character. And that's not the correct character that you're trying to decode. Yeah, for an Sigma, let's check out your setup. Oh, some characters can be encoded in multiple ways. Is that because like different languages share characters? Like a lot of languages borrow some things from the Latin alphabet. So like you have the uppercase A, that's A in Latin, and it's alpha in Greek, and the Russian alphabet has the same thing. All right, let's see what you've got here, Fern of Sigma. Hopefully this isn't porn. All right, Fern of Sigma's setup. Hey, that looks pretty good. This is on a phone. Nice. What color theme are you using, or color scheme? Oh, cool. You have some special characters here too, so you don't have to go to like the completely different keyboard layout. Looking good. Like A with umlauts is typically encoded as a single Latin code point. Okay. Yeah, there are lots of things about Unicode that I don't know. Tokyo Night. Oh yeah, I've heard of Tokyo Night. I'll have to look into that color scheme. Oh, ligatures. Yeah, ligatures are cool. Okay, so I think this feature is working. And the next thing to do is write some unit tests. So let's go ahead and do that. Let's jump to my unit test file. Let's start out with just one test. First of all, let's see if my existing tests are broken or not, because hopefully what we just did hasn't impacted any of the old tests. Yeah, Unicode is horrible, but it's the best we have outside ASCII only. It's the worst form of character encoding except for all the others. Okay, so the old tests are all passing. Let's add a new test. Let's start with something simple. Oh yeah, I have a whole compound assignment unit test routine now, so all of that stuff goes into here. Let's copy paste something. So J is 10. I don't like using the same numbers for every test, so let's do 7, the dreaded 7 multiplication times tables, times 6. Yeah, how about 6? Because I like the number 42. So that should be 42. Let's test that. That didn't work because I did plus equals instead of times equals in the test. There we go. There's a unit test of times equals. Yeah, POG stuff for no sigma. I think I'd like to commit this right now since it seems to be working. And then I can do, maybe I'll do more unit tests off screen. I think writing tests is kind of boring. I don't need to do that during a live stream. But I do want to refactor my binary expression evaluator so that it uses this function. Right now we're only using this function for compound assignment. Write a fuzz tester. Yeah, I should. I should try this a bunch with random numbers. For integers, that should be okay. For floating point, there are going to be like different rounding errors with every operation, so I have to be careful with the tolerance. Did you make an optimizing compiler? That's impressive. Yeah, you find a lot of corner cases. Yeah, so as you can see right now, I have all of my unit tests hard coded or like defined by hand. So it's like one line of code for one test, or sometimes I have like a whole Syntran source file, which makes up a test. But I write all of those by hand, so I only have like 400 tests right now. Yeah, I should do fuzz testing where I have like a loop that makes two, maybe random numbers, maybe pseudo-random. It's probably not super important how random they are. But yeah, I should make a loop that does like thousands of tests and see if all of those pass. Yeah, that's pretty cool, a just-in-time compiler. Uh, I, when I started this project, I wasn't sure if I wanted to make an interpreter or a compiled language. Uh, See you later, Buggy Worm. Thanks for tuning in. Uh, yeah, I wasn't sure whether I wanted to make it compiled or interpreted, but I decided to just save myself from work and keep it simple by making a compiled language. Yeah. Let's check out your just-in-time compiled language. Uh, I'll have to try this out. How to build. Yeah, I want to see how to build it. C-lang. Ooh, I'm a GCC guy. That's okay. I can install C-lang. I heard somebody call C-lang the Zoomer compiler recently. I don't know if that was supposed to be derogatory or what. Yeah, I'm definitely going to check this out. Theoretically type make and just see if GCC works. I want to see if I have GCC or C-lang installed. It's thinking. No, I don't have it. But like, yeah, I could just install it, so that shouldn't be an issue. Yeah, I'll try that out later. Yeah, so we have times equals, oh, I want to commit. Is that the whole diff? Sorry for scrolling through this again. I know I just did it. Yeah, that's it. Status, I don't think I added any new files. That's it. Next thing I want to do is refactor. So if you see my star token, wrong file. If you see the star token, this is S star, this is exponentiation. Fortran also uses star star as the exponentiation operator. I think Python does too, so that's a fairly common operator. But not C. C has to just not have an operator for this function, and you have to use POW. I hate POW. Yeah, so if you look at the star token evaluator, it has this, and this is basically what we just made a function for. So instead of having this thing basically copy pasted in two different places, I want to just call the function that we made here. Oh, your language doesn't have a nice front end. Well, that's okay. It's a side project, right? So is this. I mean, it's not the most polished thing in the world. Oh, okay. So I see what you're saying. So is your language not designed to like write code by hand, but have other code generate code and then run that through the just-in-time compiler? Yeah, in any case, fuzz testing. Let me add that to my to-do list. I have like a huge list of things to do at the top here. So fuzz testing. I don't think I have that in here. Yeah, that's the only occurrence of fuzz in here. Okay, so let's call the function here. I'm a little bit paranoid. Instead of deleting things, I just comment them out. That's probably like some type of code smell. But I think I can just do this. Let's see if that compiles. That compiles. Let's see if multiplication still works. 5 times 6, that should be 30. All right, thanks for tuning in, Maestrin. Sorry if I'm mispronouncing your name, but yeah, see you later. Okay, so multiplication still works with that function that we just defined. So now I can go ahead and delete this, delete my to-do note. So this is starting to look clean. I used to have cases like these nested within each operator, but now I have functions for them. So we're going through one by one. Division is going to be the next thing. Maybe I'll have time for that today. So I think I can probably commit, as long as the tests still pass. All right, all of the tests still pass. Let's make another commit. I like to do lots of little commits. I think some people work for an entire live stream and then make one commit at the end, but that's not really my style. I think I might need to refill my coffee. So I might take a small break just for like 1 or 2 minutes. Yeah, I'm gonna refill my coffee and I'll be right back. All right, I'm back. So, we have a decision to make now. What should I work on next? I could do compound assignment with division. So like I divide equals 2. That might be kind of boring because I just did times equals, and then divide equals is going to be the same idea. And this will be like the third stream in a row where I've worked on just compound assignment. Or I might be able to start working on substrings. So right now I have character indexing in strings. So you can make a string like s equals hello. That will just print. It says hello. And you can access one character. They're indexed from 0, so we have character 0, character 1, and character 2. So if we do character 1, that should be E. And now that should just print E. There it is, just the E from hello. I have character indexing, but I don't have true substring indexing. Like if I wanted to do S from 1 to 3, according to my convention, that should be EL. It should be 2 characters long. It should start at 1, and it should end at 3, but not be inclusive of the upper bound. So if anybody is still watching and has a preference of which feature I work on next, let me know in the next minute or so. Let me check the GitHub actions. I want to make sure that the last couple commits are passing in the CI. Yep, so everything's passing here. That seems to be okay. Okay. I've already been streaming for an hour, so I don't think I can finish the substring feature. But I think I might be able to start it, at least. What happened? Does this parse? This shouldn't even parse. Yeah, there we go. I forgot to save the file. Yeah, I kind of don't feel like working on division compound assignment right now. So what other operators do we need? We're going to want modulo equals. And I think I need logical compound assignment too. And I think I've decided that I'll call that and equals or ampersand equals and pipe equals. Eventually I might have bitwise operators, but as of now I don't have any bitwise operators, so these will be like logical operators, not bitwise operators, at least at the beginning. Yeah, so I think I might get started with substrings. I probably won't be able to finish it in this stream, but maybe we can at least parse things, if not evaluate everything correctly. And I should do that in my parse subscripts function. So this is a subscript, and this is also a subscript. So Syntran, at least my vision for this language is for it to be an array-oriented function, or array-oriented language, just like Fortran. One of the nice things is that you can work with multi-rank arrays. So like matrices, which are rank 2, or even things that are more complicated than that, like rank 3 or whatever type of array. So if you have a matrix, like a 3 by 3 matrix of zeros, you would initialize it like that and then refer to one of its entries like this, 1 comma 1 or 1 comma 2 or 0 comma 1, whatever. So again, this is a subscript, and the function that parses these things is the parse subscript function. Or is it plural? Yeah, it's parse subscripts. So for a rank 2 or higher array, you can in general have 2 or more subscripts. So this is also where I want to handle the substring parsing. And when you have a range of characters within the substring, I'd like to use the colon token to denote that range. So I need to parse this. But right now it doesn't parse. The colon is an unexpected token. So let's see if we can get that parsing. All right. I like to run tests more frequently than I need to. So where does this get called? This gets called from a couple places because you can have subscripts on the left-hand side or the right-hand side of an assignment operation, and those are parsed in different places, so there are multiple calls to the parse subscripts function. Like, is this the left-hand side? I think the left-hand side is first. Yeah. So the left-hand side is the first call, and then there's the definition, and then here's the second call. We're at like line 4000, so this is the second call to parse subscripts. I mean, the changes are going to be implemented inside of this function, so I shouldn't have to worry about where it's getting called. Basically, it checks if there's a bracket. If there's no bracket, then it returns early and returns 0 subscripts or an empty array of subscripts. So that's how you just deal with a scalar or an entire array. But if there is a left bracket, like if it reads an identifier and then it reads a left bracket, then it continues on into the main body of this parse subscripts function. So you can have multiple subscripts for higher rank arrays, so it parses all of those within a while loop. And this whole thing basically parses one expression because you don't necessarily have a literal integer for a subscript index. It could be an expression, like it could be a variable, or you could have like an arithmetic expression. And it pushes those into a vector. And then at the end, it converts that growable array to like a static array. So within this, we also need to handle range expressions, like a lower bound colon upper bound. Where is the comma? There should be, yeah, so it expects there to be a comma delimiting each subscript. And if there's not a comma, then it guesses like it should be a right bracket. If there's not a right bracket, there should be a comma in between each subscript. And in that case, it continues with a loop, or if there is a right bracket, then it breaks the loop. So that's how this function works. Yeah, now let's check for colons. Because what does it actually read? It pushes a subscript. And what type is subscript? Subscript is a syntax node. I want to make this kind of future compatible. So I want to be able to use a range like this, but I also want to use a range with a step. So like if you wanted to do every other character in a substring, or if you wanted to reverse a string and step in the negative direction, I want you to be able to use syntax like, for example, to reverse. Let's go 2, -1, -1. This is the starting character, so 0, 1, 2. This is the step, so -1 means step to the left instead of step to the right. And then this is the ending character, non-inclusive. So we'd step from 2 to 1 to 0, and then not include the -1. So that would be like reverse LEH. This should be EL. So that's the way that I want this to work. And eventually I want to have the step in here. But for now, I just want to have the lower bound and the upper bound. So how do I want to handle that? Subscripts vec. What does this return? This just returns subscripts. Why? Oh, Fortran. Yeah, Fortran uses this convention for some of the copy functions. So you have the source here and you have the destination here. So how does this work? It just assigns to the subscripts member of the expression. And then if we look at that, those are also just syntax nodes. And then how is this evaluated? So there's a special case in the evaluator for strings. And then if it's not a string, but it has a subscript, this is some other type of array. So I also have to think about the subscript eval function. This takes a syntax node, which is the entire group of subscripts. Because if we have a multi-rank array, it needs to convert that down to a rank 1 array. Because everything internally in Syntran is a rank 1 array, even though Fortran supports multi-rank arrays. So how do I want to handle this? This could be pretty tricky. I might not make any progress on this in the rest of the stream. So I want to break this out into subcases. If it's just a single character, well, the type is always going to be a string type. This is always going to be a string type regardless of the case. So I need to break this out into subcases. If we're indexing one character, I want to do this. Otherwise, if we're indexing a range of characters, then I want to do something else. Like instead of just this, for a single character, I want this to be some range. And I want to do that by checking if something is allocated, kind of like this. How do I want to handle that? It's tricky because some subscripts might have a range and other ones might not. Like, eventually, when you have a matrix, you might want to do that to get a column. I think this is a column. I might be transposing mentally. Or you might want to do this to get a row. Right, so like this, we have row, then column, so if we have all the rows, that's one column. That's column 0, or this would be row 0. So if you do something like this, you could have a range for one subscript, and then just a scalar for another subscript. So that makes it complicated. You don't really have to worry about that yet, because right now I'm only doing strings. And maybe I'm just doing scalar strings, not arrays of strings. So we might not really have to worry about that yet. I think I want to comment all of this out. And I'm not going to do the step yet either. For now, the first thing to do is just a lower bound and an upper bound with a unit step of 1 in between. Like, I don't need to worry about it yet, but I also want to write code that's future compatible with the features that I'm going to add later. So I kind of do have to worry about it. What did I change? Okay, just comments. Maybe I shouldn't have attempted to do this on stream because I have to like look at this code and think about it more than actually doing anything. So the subscript itself is a syntax node. And like right now, these are scalar subscripts. And the question is, when I have a lower bound and an upper bound, how do I want to store this in the syntax node tree? Like, let's say I call it U subscripts for upper bound subscripts. Do I want to have a parallel array here with subscripts and U subscripts, or do I want to store those inside of this syntax node, because this is just a reference to another syntax node type? And the question is, how do the subscripts work right now? For that, I want to look at the evaluator. And it is just an expression, right? Because this could be like a name expression. Man, this is complicated. Oh, and strings are actually a special case in here too. I forgot about that. Yeah, I don't actually handle string arrays properly yet. You can't index those by characters. So I think I want to have a parallel array that's right next to the subscripts. Character am I at? I can't see the character count. That's underneath my camera. So this is going to be like the upper bound of a subscript range, and then eventually I might have a step. So S subscripts. That would be the step. We're not going to do the step yet. But for now, U subscripts is going to be the upper bound of each subscript. And if it doesn't exist, then it's just a scalar. But how do I want to denote if it's defined or not? That's the hard part. If I'm only doing scalar strings, then I don't really need to worry about it all that much. Maybe I need like a subscript kind. I definitely need an array kind. I have that in my to-do notes somewhere. Yeah, so for for loops, I need to refactor the way that those work. And then I have explicit and implicit arrays. But I need more types of implicit array. I think I have a to-do note about this. Yeah, I need several more types of implicit arrays because it could be a range with a unit step, or like a range and a length, or a lower bound and an upper bound with a non-default step that's not one. So I need more kinds like this. And now the current question is, how do I want to handle subscripts? Maybe what I should do is have an array for each subscript. But that seems complicated. I need something for the type of each subscript, or the kind, to say whether it's a scalar or a range. So I think we need more things in the num. So we could have a scalar subscript. Let's call that scalar sub. Or we could have a unit range sub. Scalar. What do I want to name these? So scalar is the simplest case. That's just one number per subscript. Or it could be a range with a lower bound and an upper bound, or it could be a step with a lower bound, a step, and an upper bound. And those are the only three options. For float arrays, I have different ways that you can initialize them with a lower bound, an upper bound, and a size rather than a step. But for integers, and subscripts have to be integers, you can only have a step. You can't have like steps of a half. So range is going. Do I want to call this unit step, or do I want to call it range? I think I want to call it range. And step is a range with a step. So let's get those set up. I got that backwards. This one needs the comma. This one doesn't. Okay, I think that'll work. How do I want to call these? I think it's just going to be the same thing here. Nope. might as well type it out here for the human readable version of it. And I need one more space. Then get those commas. Okay, I think that's everywhere that I need to add the nums. Hopefully that shouldn't break anything. I barely changed anything. All right. Now, every time that I parse a subscript, I want to call it a scalar subscript by default. So basically a subscript has a kind, and the kind of a subscript is going to be one of these three things. So when I parse it, the usual case, which I'm currently supporting, is a scalar subscript. And this needs to be a new member of the syntax node type. So it has a kind, and then the subscripts. Does this need to be an array? Oh my god, this might need to be an integer array. No. No, I don't think it does. This language isn't super memory efficient. Well, I don't know if I want to say that. Right now it is memory leaks, and that is a straight up bug, which I need to fix. Other than that, I'm not sure that this is memory inefficient. But this feature will be, because I'm always going to allocate the subscripts array, then I'm always going to allocate this too, even if it's just a scalar subscript. And when I add steps, I'm always going to allocate that too, and they're all going to need to be the same size. So that's not like the most efficient thing to do, but who cares? This is a toy language. It's not meant to be serious and well-performing and optimal. And where do I put this kind? The kind is going to be nested inside of here. It's just going to be an integer. Subkind for the subscript kind. What did I just do there? There we go. What is my... Okay, it's a little bit of a long line. So when I parse the subscripts, I need to set that scalar subscript as a default. And I want to do that inside here. It already checks if it's an integer or not, so that's pretty good. I haven't totally skipped my duties in the type checker. And then we push it here. So before we push it, we have to have all of the members of the subscript defined. So here, I think I can say subkind equals scalar sub. As the default, I think I can do that, and that should still compile. Oh, right. Do I need to do anything to copy this member? I think I need to explicitly copy this member. Yeah. I don't know if I'm not using Fortran correctly or not, but somehow whenever I add a member here, I have to explicitly copy it in my user-defined copy function. Because this is like a recursive type. A syntax node can contain references to other syntax nodes. And if you don't do that with allocatable or pointer members, then you end up having like an infinite memory data structure. So somehow, because of that, I have to have a user-defined copy function. And every time I add a member here, I have to explicitly copy it. So what did I call this? I called it subkind. I'm going to need to copy that and copy the U subscripts, because those are the two things that I've added. Integers are not super complicated. You can just copy them because they're built-in types. So we copy that thing like that, and then U subscripts is different because that's an array and it's an allocatable array, so we have to check if it's allocated first. And those are references to other syntax nodes, so we have to recursively call the copy function within this top level copy function. So I feel like there's probably an easier way to do this, but this is the way that I figured out that works. And it's been working pretty well so far, as long as I remember to modify this code every time I add something to the syntax node type. If I don't, then I end up with like horrible memory bugs. But if I do, it works. And this is like non-trivial Fortran code, so like, hey, if I found something that worked, I'm just gonna stick with it. That should still compile, and it shouldn't crash anything in the tests. All right. So I copied U subscripts, modified all three of those. Right. And I copied the subkind as well. So in the parse subscripts, I set this kind as the default. Actually want to take a screenshot of this so I can look at that in my other monitor while I go and modify this. You probably use like a Vim split, but this is just my usual workflow. And then in the evaluator, we need to break this off as a special case. No, or do I want to do it where I call the evaluator? I'm only worried about strings right now. I'm not worried about other types. So I want to check, I want to break it off into a special case here. I want to check that thing that I just defined in the parser. So if node subscripts, it's plural. This is a string, and it's a scalar string, so we don't have to worry about higher rank arrays. So we can hard code the 1 right there. All of this is going to be more complicated for general purpose higher rank arrays, but for strings, we can hard code things and make some simplifications. So if the sub kind of that is a scalar sub, then we go into this case. Else, let's just add a to-do note. Let's see what happens. All of the tests passed. Alright, I've been streaming for a while. Can I finish this feature? I don't know. I'm gonna refill my coffee. There we go. Big old BRB in the middle of the screen, so this will just take a minute. Alright, I'm back. Okay. So all those tests passed, and now is this? No, it's not even gonna parse. This still should not parse. So it says unexpected token : and we need to parse that. So we parse a subscript, check its type, and then we don't want to push it yet. First of all, I have to set up a new array for the upper bound. This is a function. So I might have to make this a subroutine instead of a function because it's going to return multiple things. subscripts, and then at the end it gets copied into a flat array. So they're going to need to be U subscripts 2 for the upper bound of the range. So this needs to be a subroutine, not a function, so it can return multiple things. It's still a procedure. I don't need to change that. But instead of calling it like this with a return value, we need to call it as a subroutine. It's no longer a function. Is this in out or is it just out? I think it's just out. And then again, this is a subroutine now, not a function. Then where else is it called? I already did this somewhere else. So one of those calls was the left-hand side, this is the right-hand side. And there we go, we just converted that from a function to a subroutine, so that the tests should still work, hopefully. All right, wasn't even sure if that would compile. So now we need to add other arguments for the other output arguments of this subroutine. Instead of like passing this, I just want to pass the expression, but maybe we'll do that later. For now, I'm just going to add it as a second argument. And then do that in the other place that we call it. And this is going to be an other out argument. This line is a little too long. That's an array of subscripts. But we need the types too, don't we? No, yeah, so the kind is part of subscript, so we don't need an extra argument for the kinds. I'll do that later. And this should still pass all the tests. All right. Now we have to actually parse it. So we want to do something like this, except instead of checking for a right bracket, we want to check if it's a colon for a range. Otherwise, we'll do this. I think this is the basic logic. No, let me just paste that. This is going to be range, which is a unit step. So I have to actually parse it, but for now, if we look at the last run attempt that we made, do I have to scroll too far up? Yeah, if we look at this last attempt, the colon was the unexpected token. So now, okay, no, I do need to consume the colon, actually. So we need to match the colon. Now it should, the 3 should be the unexpected token. If I did that correctly. Yep. Yeah, so we're getting the colon now, and then we're getting the colon now, and the 3 is the unexpected thing. So that's good. Now we have to actually parse that thing. And we're going to do it like this. But it's going to be U subscript instead of subscript. I have to push something here because I want all of these arrays to be the same size. I want the U subscript array to be the same size as the subscript array. So even in this case, I still need to do something. Can I like just initialize this to an empty node? Because I can't leave it uninitialized. But the basic idea is that we're going to parse it like this. And we'll need to do type checking. And we already set the kind. And then we're just going to push everything. And we need a new vector for that. The underscore vect thing is just a growable vect. And then at the end, we need to copy all of them. Just add the prefix U in front of everything because that's the naming convention that I've picked. And what is that going to do? I don't really know. Is there like an unknown type? There's an unknown type. Is empty type. Like I need to initialize this to something, right? Okay, let's see what happens. That didn't work at all. Okay, here we go. The error message was above all the warnings. Okay, that's easy. I just forgot to declare something. 3548. Use subscript singular. Okay. Yeah, that's different. I think I need a quick break. All right, I'm back. Hopefully my audio is working. I muted myself, and I think I unmuted myself, but let me know if you can't hear me. I guess. Yeah, this stream is getting pretty long, but it would be cool if I could get this feature working in some minimal way before I have to take a break and eat lunch. So let's see if I can get it done. Attempt to deallocate oh, it gives me a line number, 1424. Is that going to mean anything? What the hell is this? Push. First of all, do my tests work? No, I have done something horrible that broke all of my tests. Because I can't push something that's uninitialized. I think noon is my cutoff. If I can't get this done by noon, then I have to just stop and take a break. Maybe I just need to do this. I think it's going to be more complicated than that. Yeah, it's more than just that. Oh. Is that all? Yeah, that's what I needed. I forgot to initialize the vector, my growable data structure. So I might not need this. All right, that wasn't so bad. And then what happens if I run? Hey, it's getting to the evaluator, I think. What did that just say? Substring ranges. Yeah, this is the evaluator. So that's going to be the lower range. Do I have integers set up for these things? This function is way too long. This function is way too long. I, J, L type, R type. Let's call it IL and IU for I lower and I upper. IL is that. That's the lower bound of the subscript range. And then we need the upper one too. But it's going to evaluate a different member of the syntax node. Specifically, we want the U subscript member. And for that, I think we can use syntax eval. Do I have a call to that somewhere? Yeah, we can copy and paste this thing. Pass all of that boilerplate. And that might work. So let's see what that does. Nope. Oh. It's going to be a value type. Step, and let's just reuse right. I don't want to redeclare something new. Because this could be any type of value, but it better be an integer. So this returns a value. So we have to use this temporary value object and then get the integer from it there. What did I just do? Oh, I changed the wrong one. Will that work? It's thinking. It's thinking. We are so close. We have the lower bound 1 and we have the upper bound 3. Now we just have to return the substring. This feels horribly hacked together, and it's not going to be easy to extend this to arrays of other types, but it should at least work for substrings, I think. And I think we're almost there, and I'm going to be able to get this done before lunch. So don't really need to return an error. Now we get the range. Instead of I plus 1, it's going to be left bound plus 1 to the upper bound plus 1, or lower bound to upper bound. It's not right to call it lower bound and upper bound because the upper bound could be lower than the lower bound if you have a negative step. But this is the convention that I've stuck with. Maybe I should call it like the left bound and the right bound. But then I have to like rename everything that I've done everywhere else. And I'm not going to do that. I'm just going to stick with my existing convention. Oh my god. It's wrong. Yeah, it's off by 1. So we are not inclusive of the upper bound. That's the way that ranges work in Python. That's the way that ranges work in a lot of programming languages. So, like, this should return EL. There it is, EL. Let's try like a slightly less trivial example. Let's try to get world as a substring. So we have 0, 1, 2, 3, 4, 5, 6 through 7, 8, 9, 10, 11. 6 through 11? I think it should be 6 through 11. There it is, world as a substring from the hello world string. I think that's it. I just want to add a test quickly and then commit this. This is horribly hacked together. I feel bad about what I've just done. But it works, so it can't be that bad. I've got some trailing white space. I hate trailing white space. That looks good enough. Let me get rid of some of those prints. So yeah, this isn't great, but I'll fix up some of these things later. I think I got rid of all the prints. I don't know if I remember to run my tests. All of the tests still pass. That's not what I wanted to do. That's what I wanted to run. I want to print, okay, I'm printing like everything. So that's the single character substring. We have a range, that works, and we have a bigger range. I'm not testing steps yet. Steps have not been implemented. But I want to add a unit test for this quickly. Where did I do my hello substring? Okay. One through 3 should be EL. Yep, that looks good. Let's do a couple other tests. 0 through 2 should be HE. 1 through 3 is EL. What was it, like 6 through 11 for world? And then if you try to do it out of bounds, I don't have any range checking for any type of subscript, so I don't have bounds checking for this either. That's up there on my to-do list. But I think that's it. I think I'm going to commit this. I have a few unit tests working. So let's take one last look at the diff and then commit. And then I'm going to end the stream. Looks good to me. I think this only works on the right-hand side. Yeah, this will only work on the right-hand side of expressions. If you try to like assign something to a substring, that's not going to work yet. So maybe I should have put that in the commit message, but oh well. Let me confirm that that pushed. All right, the tests are running. They passed locally, so I'm pretty sure they're going to pass on the GitHub Actions CI. So that's it for today. Thanks for everybody who tuned in, and I'll catch you next time. Bye.